Welcome to Maths and Science by IITian channel. We are continuing our discussion on complex numbers. It is the lecture number 2 for complex numbers. Complex number 2 for the benefit of IIT JEE and Math Olympiad, and also for CBSE Board Examinations. In the last class, we have discussed about e to the power of ix. Now in this class, we are going to discuss about sin x and cos x in a series form. Sin x is represented by which series and cos x is represented by which series, using the complex numbers knowledge. And I am from Maths and Science by IITian channel. If there is any value addition to your knowledge, please share, view, review and comment on my videos. 40 lectures are released from this channel, and please subscribe to my channel. Let's go further. In the last class or in the last lecture, what we have learned is that e to the power of ix is equal to summation of from n is equal to 0 to infinity ix to the power of n by factorial n. This is the form which we have discussed in the previous lecture. This is equal to, this also we have discussed and derived, cos x plus I sin x. When we expand the left hand side, we get 1 plus ix plus ix whole square by factorial 2 plus ix whole cube by factorial 3. This also we have discussed at length in the last class. That is equal to cos x plus I sin x. And this, for any algebraic or complex number when we are dealing with, let's have a geometrical interpretation also. It is x-axis, it denotes the real numbers, and it is y-axis, it denotes the imaginary numbers. And we know pretty well that a point P with x, y, z is equal to x plus iy. Let us say this point can be, let us say z instead of p. We can even say it's z. Zxy, z is equal to x plus iy. That is coordinates x and y. X is the real number. I am slowly going forward to make you understand. This is origin O. We can call that number as z or p, whatever we want to call. And if we call it as z, you call it as p, that's up to you. You can call by any name. And in a straight line, OZ is a straight line. In a straight line, the quantity of OZ is equal to square root of, what is the quantity of OZ? That is equal to square root of x1 minus x2 whole square plus y1 minus y2 whole square. If you remember your secondary school examination mathematics geometry, if x1 y1 are the two numbers, then distance between those two numbers is square root of x1 minus x2 whole square plus y1 minus y2 whole square. What is x1 here? It is 0, 0. x2 is xy. Second point is xy, z, oz is equal to square root of 0 minus x whole square plus 0 minus y whole square. That is equal to, why I have put this absolute value? Because distance cannot be negative. Hence, even the negative value comes, we have to convert into positive only. Distance can never be negative. Please try to understand. Square root of x square plus y square. That is the OZ. Now, we will come back to our original equation. This is what is the little understanding I have given out of the context, because on this basis only we are going to do our complex numbers and complex algebra or complex analysis. I am giving slowly more and more concepts with the progressing of each lecture. Now, what we have till now is our knowledge e to the power of ix is equal to 1 plus ix minus x square by factorial 2 plus again minus I into x cube by factorial 3 plus x to the power of 4 by factorial 4 plus so on. This is e to the power of ix, which we have derived in the last class from the Taylor series. We have used the knowledge from Taylor series. Now, when you separate real numbers, x we thought it as a real number. When we separate the real numbers and imaginary numbers separately in the above expansion, Taylor's expansion, e to the power of ix is equal to 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4 plus so and so plus I into x minus x cube by factorial 3 plus x to the power of 5 by factorial 5 and so on. But from the basics of the complex numbers we know, which we have derived in the last class, e to the power of ix is equal to cos x plus I sin x. Comparing the imaginary parts and real parts. Comparing imaginary and real parts. You see, this is compared, this is the real number, is compared with cos x. And this is the imaginary number. I into something is imaginary number. This will compare it with sin x. It is not sin theta, rather sin x. Then from above, what do you write? Cos x is equal to 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4 plus, and sin x is equal to x minus x cube by factorial 3 plus x to the power of 5 by factorial 5. That means, what are the final values we have got here? Cos x is equal to 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4. Can we write in this form? In summation form, n is equal to 0 to infinity minus 1 to the power of n into x to the power of 2n divided by 2n factorial. Because if you see the denominators, it is 2 factorial, 4 factorial, 6 factorial, that is 2n factorial. If you see the numerator, that is when x is equal to 1, when x is equal to 0, that is 1 value, and when x is equal to 1, it is minus 1 to the power of n. It is x square, that means x to the power of 2 into 1. That means we can write in the Taylor's expansion as cos x is equal to sigma as a summation infinity minus 1 to the power of n into x to the power of 2n whole divided by factorial 2n. This is the value of cos x. Now, we will come to the value of sin x. Sin x we have compared with what? I value, imaginary value. X minus x cube by factorial 3. Sin x is equal to x minus x cube by factorial 3 plus x to the power of 5 by factorial 5 plus so on. Can we write this in a summation form? Sigma, let us have sigma correctly. Sigma n is equal to 0 to infinity. The series is up to infinity, starts with 0, minus 1 to the power of n into x to the power of 2n plus 1, because x is in odd number. When n is equal to 0, it is x to the power of 1, n is equal to 1, it is x cube, n is equal to 2, it is x to the power of 5, so that x to the power of 2n plus 1 form, and divided by, what is the factorial? When n is equal to 0, it is factorial 1, 1 can be written as factorial 1 is equal to factorial 1. Then we can write it as 2n plus 1 factorial. 3 is 2 into 1 plus 1, that is 2n plus 1. That means sin x is equal to summation of sigma n is equal to 0 to infinity minus 1 to the power of n into x to the power of 2n plus 1 whole divided by 2n plus 1 factorial. This is the value of sin x. By chance, in the examination, it is asked to find out sin 10. You can find out from this. and here x is in radians. X is in radians. You please remember 2 pi radians is equal to 180 degrees. That means 1 radian is equal to 180 by 2 pi degrees. That means 1 radian is equal to how much? 180 by 2 pi you do? 180 divided by 2 divided by pi. 2 pi radians is not 180, sorry, it is 360. It is for the whole circle. 360 degrees. I am sorry, I have written it as 180 by mistake. It is pi radians is equal to 180. This is 2 pi radians we have taken. It is 360. 1 radian is equal to 360 by 2 divided by pi, that is 57.3 degrees. This relation is also very important relation as far as complex numbers and mathematics is concerned, and please try to understand these concepts also. And cos x and sin x, we got the value, and whenever x is equal to 0, when x is equal to 0, let us try to test the series, whether the series is correct or not. What we have got? Sin x is equal to x minus, why I am repeating, this is very important to understand and to remember. When x is equal to 0, what happens? Sin 0 is equal to 0 minus 0 cube by 3 cube plus 0 to the power of 5 by factorial 5, that is equal to 0. That means our series is compatible with whenever sin 0 is concerned. Now, let us try for cos 0. Cos x is equal to 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4 and go on. That implies cos 0 is equal to 1 minus 0 square by factorial 2 plus 0 to the power of 4 by factorial 4 and so on, that is equal to 1. That means sin 0 is equal to 0, cos 0 is equal to 1. These are called as boundary conditions, are satisfied. For the series what we have written, as a homework, please check for pi by 2. Sin pi by 2 is equal to 1, the real values. Cos pi by 2 is equal to 0. Is it correct or not? That is your that's your homework. For example, I will do partially. What is cos x? One minus x square by factorial 2 plus x to the power of 4 by factorial 4 and go on, so on. let us say x is equal to pi by 2 radians. That is nothing but 90 degrees. Pi by 2 radians. That implies cos pi by 2 is equal to 1 minus pi by 2 by whole square by factorial 2 plus pi by 2 by whole to the power of 4 by factorial 4 plus so on. What is pi value? 3.1416. That is equal to 1 minus 3.1416 by 2 whole square by factorial 2 plus 3.1416 by 2 to the power of 4 by factorial 4 plus so on. We are only roughly calculating because up to infinity we can't calculate without calculator. Cos pi by 2 is equal to 1 minus. What is 3.1416 by 2? That is 1.571. 1.571 square by factorial 2 plus 1.571 to the power of 4 by factorial 4 plus so on. That is equal to 1 minus 1.234 plus 0.254, that is approximately equal to 0.02. That means cos pi by 2 is tending to 0. When you further calculate in the series is validated. Now the observed series are validated for x is equal to 0 and x is equal to pi by 2. And we by binomial theorem we can say that it is x1 value, it is x2 value. We can say that this particular series is valid or verified for other values of x. Hence, what we have studied till today, e to the power of ix is equal to cos x plus I sin x. It's a valid equation. We have just verified from this whatever we have derived using this. This e to the power of ix can be written in the summation form as n is equal to 0 to infinity ix to the power of n by factorial n. This is our first observation in the first lecture. Second observation is sin x is equal to x minus x cube by factorial 3 plus x to the power of 4 by factorial 4 plus so on. That is equal to, in summation form, sigma n is equal to 0 to infinity minus 1 to the power of n into x to the power of 2n plus 1 whole divided by 2n plus 1 factorial. What is the third observation? Cos x is equal to 1 minus x square by factorial 2 plus x to the power of 4 by factorial 4 plus so on. That can be written in a summation form. N is equal to 0 to infinity minus 1 to the power of n into x to the power of 2n whole divided by 2n factorial. These are the final observations, and from that we have derived that sin 0 is equal to 0, cos 0 is equal to 1, sin pi by 2 is equal to 1, and cos pi by 2 is equal to 0. These are the observations we made from this series. This series will be very useful to us in future classes of complex numbers, and complex numbers should not be studied individually, they should be studied in a complex plane like this. It's a complex plane. This is 0, this is z, xy, and OZ is equal to square root of x square. What is that we have got? Square root of x square plus y square. That is the magnitude of that line. With this, I want to conclude this class, and it's from Maths and Science by IITian. In the next class, what we will do, we have studied the theory in the last two classes on complex numbers. We will go for some good examples, maybe of JEE Advanced standard or JEE Mains standard. Some good examples, Olympiad standard good example with this background, whatever we have studied till now. Best of luck to everybody. Thanks for seeing my channel video, and thanks for listening to me. And we will go for the example. My approach will be like this. First 1 or 2 classes will be on theory, on the topic in which we have started, and after 2-3 classes I will take one good example of the standard of IIT JEE Mains or Advanced, or Maths Olympiad, and these will be useful for CBSE Board Exams also. Best of luck to everybody. Thank you, and please subscribe to my channel. Maths and Science by IITian. I will give the playlist link in the description of this video.